lecture. So a quick review on what we had done in our last class. We started with the topic electrolysis, which is one of the important topic of your IGCSE, and it's a different topic. Okay, so over here we studied about how electrolysis takes place. What are the things which are required in electrolysis? So we need a beaker or a vessel which is made up of glass or let's say plastic. Then electrodes will be there. Then electrodes are connected to two terminals, positive and negative. Positive terminal will be anode, negative terminal cathode. At positive terminal, oxidation takes place and negative terminal reduction takes place. So we have generated one word as PAO, positive anode oxidation. Then we studied about two electrolytes. One was molten electrolyte, that how electrolysis will take place when there's a molten compounds, and how electrolysis takes place when there is a dilute solution. So these two different rules for molten. For molten, there is like actually no rule. Molten compounds means you strictly have to understand positive ion will go to negative cathode and negative anion will go to positive cathode. We don't have to remember any reactivity series, neither any rule. But yes, when we do the electrolysis of dilute solution, there is a rule. When it is cathode, then at cathode there will be two cations, means two positive ions will be there. So the cation which is less reactive will be discharged at cathode. We did an example of KCl. So K plus and H plus. H plus is less reactive by looking at the reactivity series. So hydrogen will be liberated. And when we did CuSO4, that is copper sulfate, dilute aqueous, between hydrogen and copper, copper was less reactive. Over here, if you can see, so copper was liberated. And the rule for anode remains same, that is for dilute, it will always be hydroxyl ions. Okay. So this was about the dilute aqueous solution. And now let us move ahead. Let us move ahead with the concentrated electrolyte of concentrated aqueous solution. So lecture 2, electrolyte will be concentrated aqueous solution. At cathode, what will happen at cathode? At anode, and electrolyte left. So let's take an example. First one, let's take concentrated NaCl. Now, when we talk about the word concentrated, now concentrated is something, yes, there will be addition of water, but the amount of water will be less. It will be comparatively less. So yes, it is NaCl plus H2O, but concentrated means H2O in less quantity. H2O in less quantity. So Na plus Cl minus H plus OH minus. So there will be total 4 ions, 2 cations and 2 anions. Now Na plus and H plus, once again there will be a competition that who will discharge at cathode. The rules remain same. The rule remains same. That is less reactive cation. That is positive ion. Okay, less reactive cation will discharge at cathode. Okay, so yes, Akbar, tell me Na plus and H plus, who is less reactive? Which is less reactive cation?
H plus.
Correct, very good. So it will be H plus. Okay, Kashni, at cathode, what happens? Reduction or oxidation?
Reduction.
Yes, at cathode, reduction. Arnav, can you tell me what is reduction? Is it gain of electrons or loss of electrons?
A reduction is loss of electrons.
No,
Sorry, gain of electrons.
gain.
Sorry. Yes,
Oil
sorry.
grade,
Yeah.
yes, it's gain of electrons. So H plus electron will give me H. Jessica, is hydrogen diatomic or monatomic?
It's diatomic.
Yes, so we have to write H2, 2H plus 2 electrons gives me H2. So this is my equation for cathode. So it is the H plus which got liberated, and what is left? Na plus. So out of H plus and Na plus, H plus is liberated because it is less reactive. Now at anode, the rule changes. In dilute, where there were more OH minus ions, okay, in dilute where there were more OH minus ions, since OH was in more amount, it was always OH minus, and oxygen used to be liberated. But over here, now it is reverse. At anode, it will be the halide ions, which will be liberated. The halide ions which will be liberated. It will not be OH minus ions, not OH minus ions. So out of OH minus and Cl minus, which ion will be liberated? Yes, Vanya, it will be?
Chloride.
Yes, Cl minus, and anode we know that since cathode is reduction, so anode is oxidation, and there will be loss of electrons. So it will be Cl minus losing electron forming Cl. We know that chlorine is diatomic, so Cl2, 2 Cl minus, minus 2 electrons. And what is left is OH minus, and that is how in the electrolyte you get NaOH. And this process, okay, this process, which is concentrated aqueous solution, so concentrated NaCl is also called as brine. Okay, that's a name given to concentrated NaCl, which is also called as brine. Electrolysis of brine is a commercial process. Commercial process. And it is also called as commercial process, and the process name is also called as chlor-alkali process. The process name is also called as chlor-alkali process. Can anybody tell me why the name is chlor-alkali process? Why this name? Chlor-alkali process. Why this name is given, chlor-alkali? Anybody?
Is it because it's made of chlorine? It's a wild guess.
Okay, one part is correct, one part, but it's not made up of chlorine, but it is because of chlorine, which is liberated as one of the products. See, you are taking as a reactant concentrated NaCl, and as a product, you are getting three products over here. Product number one is hydrogen gas, product number two, chlorine gas, and product number three, NaOH, which is an alkali. It's a soluble base. So this process is commercially very important because all the three products are like, you can say it's useful. So what are the uses of this product? Where do you use hydrogen? Hydrogen is used as a fuel. It is also used in making ammonia gas, which is NH3, ammonia gas. Also in making margarine. Margarine is your animal fat. So it's used in making fats. So hydrogen is one of the commercial product which is used widely. Chlorine is used as a disinfectant to you can say to kill germs. Second, it is used as a bleaching agent. And NaOH is used in making soaps, in paper industry, etc. So it's a very, very, very important process. So hydrogen, and what do you observe? What is the color of hydrogen? What is observation over here? Hydrogen will be colorless gas, so there will be bubbles. You will see bubbles or effervescence, and for chlorine, you will see greenish yellow gas. So this is overall thing. Anything they can ask. They can ask maybe like, they can ask you what are the products formed, or what are the uses of product for 1 mark. So definitely we are going to solve some of the questions. But this is overall view of electrolysis of concentrated aqueous solution as NaCl. Okay, so only NaCl thing is called as chloralkali process, and it's called as brine. So you guys can take a screenshot, and this upward arrow over here, this arrow means it's a gas. So please take a screenshot of this, then you can later on you can write it, because we have to do today 3 other important topics as well. We have to do the applications of electrolysis, and also we have to do electrolysis of molten alumina. That's aluminium. That's also important. Okay, done. Can we go ahead? Please take a screenshot. Everybody has taken the screenshot, so we can go ahead. Okay, so let's go to the next concept, which is application of electrolysis. Why we are learning electrolysis? That question comes to our mind, that why there's a need to learn electrolysis. Now, electrolysis has 2 applications. Number 1 application is electroplating. Number 1 application is electroplating, and second application is electro-refining, refining of metals. So now what is electroplating? So electroplating is something where, suppose if I want to electroplate something, for example, galvanization. Galvanization is coating of zinc on iron to prevent iron from further rusting. So how it is done? So that's done by a process which is called as electroplating. Let's say if there is a copper vessel which I need to plate it with gold or silver, then how am I going to do? I just can't take the layer of layer of gold or silver, and I can just coat it. That has to be a chemical process. So that chemical process is nothing but that's called as electroplating. So there are certain rules for electroplating. You cannot just do it randomly. You have to understand that how to do electroplating. So we are going to learn that. So whenever we do electroplating, so important thing again, we will need a vessel. There will be the metal bar, whichever metal I need to coat. Okay. Also remember, you cannot use a metal which is high reactive metals. Like there will be no electroplating with sodium metal, because sodium is also very explosive. So all the below low reactive metal like copper can be electroplated, zinc can be electroplated, silver can be electroplated. You can use gold for electroplating, but you cannot use calcium, potassium, or sodium or lithium because they are highly reactive. As soon as you will put it in water, there will be lots and lots of explosion. So those metals definitely can't be electroplated. Okay. So the desired metal will be there as one electrode, and another electrode will be your object. So let's say I want to plate a key. Okay, I want to plate a key. So this is my object to be plated. So at one side, there is a metal bar, and another side, there will be object to be plated. Okay. Arnav, tell me which metal you want to be plated on your key. Gold, silver, copper. What do you want?
Gold.
Gold. Okay. So let's take this is the gold bar. So the metal to be plated, it's your desired metal which you want. And this is my object. Now we need to understand that where the metal bar will be connected to which terminal, positive or negative. Any guess? Where will be your metal bar and where will be your key? On which terminal? What do you think the key will be connected to, and what do you think the metal bar will be connected to? Which terminal? Think, apply your logic. Where do you think the key will be connected? Come on, there are only two answers, either positive or negative.
Unless would the metal bar be connected to the negative terminal?
Okay. So metal bar will be connected to negative terminal. Okay, let us check. Okay. Which type of ions the metal will make? Metal undergoes dash. Metal always undergoes, no, not always, because there is another. Metal generally dash electrons. Lose or gain? Lose electrons. You have never heard about Na minus, Al3 minus. It's always Al3 plus, Na plus, potassium K plus, which means metal forms positive ions. They will form cations, which are positive. So if metal is forming positive ion, where that positive ion will attract? To which electrode? If metal is forming a positive ion, so positive ion will attract to which electrode? Yes, Kashni, yes, negative.
The
So
negative one.
yes, so can I say that the object to be plated has to be cathode? Because from metal, what is formed? Positive ions. So positive ions needs to be attracted to the negative terminal. So the object to be plated has to be always cathode. That's the rule. The object to be plated is always connected to cathode. Suppose in exam you forget, because it's a part of memorizing. Use this logic that metal forms which ions? Metal forms positive ions. So positive ion will attract to which electrode? It has to be on the negative electrode. The object has to be on the negative electrode, then only the positive metal ions will attract. And the metal gold bar means the metal bar has to be at anode. The metal gold bar has to be at anode. Now, what about the electrolyte? You cannot use any random electrolyte over here. So your electrolyte has to be a solution, metal salt solution, metal salt solution of metal to be plated. If you are plating gold, you cannot use a solution of copper. You have to use a solution of gold only. If you are plating your object with copper, you cannot use some random electrolyte of nickel. No, you have to use of copper only. And important is solution. It cannot be precipitate. You cannot use any insoluble salt. Okay, it has to be a solution. So I'm going to write it over here, some example of metal bar, which you can use it, and the metal salt solution as electrolyte. So if you are using your metal bar as gold, which is AU, your electrolyte should be AuNO3, gold nitrate solution, AuNO3 aqueous. If you are using silver, it should be silver nitrate. If you are using copper, you have to use copper sulfate, aqueous. If you are using nickel, nickel sulfate. So these are some of the common metals which are used, and on the adjacent side is the electrolyte, corresponding electrolyte, which needs to be used. So in electroplating, once again, important rule, 3 things to remember. Number 1, the metal which needs to be coated will be at anode. Object to be plated, cathode. Electrolyte should be the salt solution of the metal. Okay, is this very clear about electroplating? Any doubts? An application. The second application, electro refining. Okay, now in electro refining is that whenever there is an extraction of metal which takes place, so you extract a metal from its ore, then finally the metal which you get, you need to refine it. It's not the pure metal. So what happens in electro refining? So over here we are doing an example of copper refining. So once again, we take the vessel, we take one side impure copper and another side a pure copper metal strip, electrolyte. The impure copper, once again, it is connected because I need to plate my copper on the pure copper strip, correct? The pure copper, which is a thin sheet. I want from my impure copper, the pure copper needs to go. So again, it's a metal. So this needs to be anode and the impure one has to be the cathode. So the impure metal will be anode. The impure metal will be anode and the pure metal strip will be cathode. The impure metal anode and the pure metal strip cathode. Positive, negative. And since it's copper refining, so the electrolyte will be aqueous copper sulfate, which is blue color. Okay. What happens at cathode and at anode? So reaction at anode. Anode, it's oxidation. Oxidation is loss of electrons. So Cu losing 2 electrons, forming Cu2 plus. Cu losing 2 electrons, forming Cu2 plus. That happens at anode. And what happens at cathode? Reduction. Reduction is gain of electrons. So it is Cu2 plus gaining 2 electrons and forming copper. And that's how deposition of copper takes place on the cathode. Deposition of the takes place on the cathode. Now there is an observation over here. There is an observation over here. Can anybody tell me what could be the observation? Observation. If from impure metal the copper is deposited, what happens to impure metal? Impure metal. If from impure metal the metal is going on the cathode, what will happen to impure metal?
Will it just stay in the water? Sorry, not in the water, the sorry,
Electrolyte.
the electrolyte, yeah.
No, not really. It will electrolyte will remain as it is. Yes, there will be some impurities, the impurities which will settle down at near anode. So one observation we can see that impurities from anode will settle at bottom. But imagine that there are two rods. One is impure rod, one is pure rod. You are doing electrolysis process from impure rod. From impure rod, the metal is getting deposited on the pure rod. So can I say that there will be a difference in the size after some time? The impure metal will start diminishing because from their impurities is settling down and the pure metal is getting deposited on what? On another metal. So the observation number 2 is the cathode mass decreases. The cathode mass decreases. Reason? Because from there the metal is getting deposited on the cathode. Sorry, anode mass decreases. My bad. Anode mass decreases, and the third one is there will be increased mass in cathode. Mass of cathode electrode increases. So this is what is the observation, because for some time, for 3 marks, they do ask observation, or 2 marks. So any 2 observation you need to write. And this is my anode impurity, which is sometimes also called as anode mud, because that's the impurities which will settle down. So please copy down this. I'm giving you 2 minutes, 2 to 3 minutes, copy down this. It's fine. You can. Okay, now over here, can I say that impure metal over here, we are doing copper. So it will be copper. At anode, can I say it is oxidation, which is loss of electrons?
Yeah.
So you are taking copper metal from which copper is losing its electron and it is becoming Cu2 plus. Now what happens is from anode, the Cu2 plus, since it's a positive one, it will get attracted to which electrode? Cathode. which is your pure metal strip, which is already made up of copper only, but it's a thin strip. When that ion goes towards cathode, the ions will accept electrons, it will gain electrons, and it will form as copper solid, which will deposit on the cathode. And that's how the size of the cathode keeps on increasing.
Okay, Miss, could you explain the charges, like why Cu in anode is neutral and then it becomes ionized?
Because what happens because it's a circle. See, copper is a metal, but when it loses electrons, what it will happen? If it's a neutral atom, can I say in a neutral atom, protons is equal to electrons, correct?
Yeah.
Now, if it is losing electron, so what will be more? If there is a loss of electrons, let's say from copper 2 electrons are lost. So can I say that in Cu2 plus, there will be 2 protons extra than electrons?
Yeah.
And that's why we wrote two Cu2 plus, because the valency of copper is 2 plus. The stable oxidation number of copper is 2 plus. So that 2 plus keeps on going in the solution. And what happens at cathode? The cathode has electrons, so it will gain electrons. Cu2 plus is gaining 2 electrons. So now, when it is gaining 2 electrons, so can I say again the protons and electrons becomes equal?
Yeah.
And that's how you get a neutral atom.
Okay, Miss, I got it.
Yeah, and that neutral atom gets stick on the cathode, which is your which is your metal strip. You can also use platinum, but the better result is the thin strip of metal. Copper is already there. We are just adding copper to that. So that's how the size of the cathode keeps on increasing and the size of the anode keeps on diminishing. Okay.
Okay, Miss.
Yeah. So just 1 minute, I'll be back. So let's go to the next subtopic, which is extraction of molten alumina. Extraction of aluminium from its ore, bauxite, or basically from, to be precise, from molten alumina. So we need to extract aluminium. That is our agenda. Now, the ore of aluminium is bauxite, which is Al2O3. Just 1 second. Okay, so ore of aluminium is bauxite, which is Al2O3. Okay, aluminium ore. It is actually Al2O3, 3H2O. Now, the bauxite is processed by removing impurities. And it is being converted to alumina, which is molten alumina. So Al2O3. Now it's a molten alumina, so we just have to extract metal, that is aluminium, from molten. So over here there is no concentrated, neither aqueous. So it will be, the process will be simple, that Al plus 3 plus will go towards cathode and oxygen will go towards anode. But the process of electrolysis is not that simple as what we have studied. That is about, the vessel. The process is little bit different. So that's why I'm going to show you that how exactly the electrolysis of molten alumina is done. Now in this, there will be a steel tank which is used. You are not supposed to remember the diagram, okay? Diagram is only for your reference. So this is a steel tank. The outer layer is made up of steel. Okay, the outer layer is made up of steel. The inner layer is cathode. There's a coating of inner layer which is cathode. And this is cathode, which is carbon lining. So the inner layer in the steel tank is cathode, which is carbon lining. Okay. Then there are anodes which are placed over here, but the anodes are made up of rods, carbon rods, graphite. So there are anode which is made up of carbon graphite rods. Okay, anode which is made up of carbon graphite rods. So this is cathode. This is anode. So cathode is also carbon lining, anode is also carbon, but it is made up of graphite rods. Then you have an electrolyte. The electrolyte over here is molten Al2O3. Along with that, remember, it's not only molten Al2O3. Along with that, they add molten cryolite, which is Na3AlF6 plus molten fluorspar, FluorSpar, NaF2. So total 3 things will be there in electrolyte. We are going to learn the reason that why cryolite and fluorspar is added in molten Al2O3. Just now we are just understanding that how it is, what all things are required. And we know that at cathode. So what will happen at cathode? Since it's molten electrolyte, so which ion will be there at cathode? Since it's Al2O3, so we know that it is Al3 plus and O2 minus. So which ion will be going towards cathode? Al3 plus or O2 minus? Who will go at cathode?
This is Al3 plus.
Correct. Al3 plus. Cathode, there is gain of electrons. Okay, don't be in a hurry to just write the answer. Take a pause, think that yes, cathode is reduction, gain of electron. That is how you will always go right. You will never go wrong. Don't be in a hurry. So yes, Al3 plus gaining 3 electrons and it will form Al. So since this red color below is my cathode, so whatever Al will be there, the molten aluminium. The molten aluminum will settle over here. And since there is an outlet over here, so all the molten aluminum will be collected over here. Molten Al. What happens at anode? What will happen at anode? Which ion will go at anode? Anode is positive. So O2 minus. Losing electron forming oxygen. Now, oxygen is diatomic or monoatomic? Oxygen is diatomic or monoatomic?
Diatomic.
So it will become O2 and 2O minus. One oxygen losing 2 electrons. So 2 oxygen will lose how many electrons? 4. And that's why we need to write 4 electrons. So this is the reaction for cathode and anode. Once again, I'm explaining O is 2 minus as a charge. Oxygen is minus 2, oxidation number. Losing electron forming O, but we know that oxygen is diatomic. Now, one oxygen is losing 2 electrons. So 2 oxygen will lose 4 electrons. And this is the reaction at cathode and at anode. So once again, I'm explaining how aluminum is extracted. The electrolyte used over here is molten alumina. Okay, electrolyte used over here is molten alumina. The cathode and anode over here is made up of carbon because it's an inert material. So cathode over here is carbon lining and anode over here is carbon rods, graphite. Electrolyte along with molten alumina, molten cryolite and molten fluorspar is added, CaF2 and NaF2. Cathode anode reactions is done over here. So now let us understand why there is this addition of electrolyte required, that is molten cryolite or fluorspar is added, because that can be one of the questions which they can ask. So now the questions. Okay, question. Why cryolite and fluorspar is added to molten Al2O3? Anybody?
Miss, is it to reduce the melting point of Al2O3?
Correct. That's absolutely correct. See, melting point of aluminum is above, it's somewhere around 1800, Al2O3. So if I want to reduce the working temperature, reduce the melting point of Al2O3, I need to add these materials so that the reduction in the melting point is by 1100 degrees Celsius. So when this overall mixture is added, the temperature becomes somewhere around 900 degrees Celsius. So first reason is, yes, to reduce the working temperature, or we can write to reduce the melting point of Al2O3. Second point, since cryolite, which is Na3Al(F6) and fluorspar is CaF2. Please make a correction. Fluorspar is CaF2, not NaF2. Please make a correction. Fluorspar is CaF2. Yeah. So both of these are ionic compounds. So if there is more and more ionic compounds, there will be more electrical conductivity because there will be more ions formed. So to increase the electrical conductivity, 2 marks, 2 points. This is one of the questions they can ask. Second question which they can ask is why anode rods, that is graphite rods, needs to be replaced periodically. Why anode rods, graphite rod needs to be replaced periodically? Yes, anybody can answer this? What is liberated at anode? What is liberated at anode? Can I say oxygen gas? Yes. Anode is made up of carbon. So if on the carbon electrode, if oxygen is coming, what will happen?
Miss, would they react?
They will react and they will start forming carbon dioxide. So can I say the carbon electrode will be used up by oxygen, and at one point of time the carbon electrode will start diminishing. It will be used up because there will be formation of carbon dioxide gas or carbon monoxide gas. So anode needs to be replaced periodically because O2 gas is liberated at anode, which is made up of carbon. So carbon reacting with oxygen can produce carbon dioxide, or carbon reacting with oxygen can also produce carbon monoxide. So because of this, the anode needs to be replaced periodically after every, let's say, few days or few hours, depending on how much electrolysis you are doing. So that needs to be replaced. So this is about the overall thing for electrolysis of molten alumina. If you see the past papers, the question do come from this molten imine extraction of aluminium, and also from the concept which we have done. Yes, we are going to solve the past paper questions, which will be our next week agenda. So when we are meeting on Monday, no, sorry, when we are meeting on Sunday. So Sunday we will be solving questions on electrolysis, because as I told you that in your IGs, the important is how to answer the questions. Concept wise, yes, we have learned, we understood everything. What type of questions are come, how to answer those questions, MCQ as well as structured, both the questions we will be solving some of the few questions, and that will be the closure of the chapter, because understanding only concept is one major part, but how to apply that understanding in form of questioning and answering, that's part 2 of the concept, which is equally important. Okay, so this was overall about the topic electrolysis. Any doubts? And yes, as I told you that though you have done electrolysis in your year 10, normally this is a year 10 topic, but it depends on school to school. But I felt to do this in year 11. Reason is because this topic is something which is a very new topic. I mean, it is not linked. It has redox, you can say concepts also. Plus, it is equally important because in structured paper as well as in MCQ, they do ask. Definitely they ask. Okay. So any doubts of whatever we have done till today in electrolysis? Yes, Akbar, any questions?
No, miss.
Okay. Arnav,
No questions.
okay. Andrew,
No questions, miss.
Jessica, Kashni,
No questions.
No questions, miss.
okay. Wanya,
No, miss.
okay. So the thing which I want from you guys on Sunday is just make sure that you are revising this chapter once again, because when we will solve the questions, okay, when we solve the questions, it will be better that you guys can revise this chapter. So when we discuss, because it is not that I will only give the answers, it will be a discussion of the answers, MCQ and structured. So you guys just prepare this topic, and we will be back on Sunday and discuss the questions of MCQ and structure. So that is our next lecture agenda. Okay, so with this, guys, we will end the session for today. Thank you very much, and I will be sending the notes as well as the recording, which will help you to revise further. Okay, so till then, bye bye, take care, and have a nice week. Bye bye. See you on Sunday.
Bye, miss. Thank you.
Bye bye. Bye bye.
Bye.
Bye.